Hey, very good morning and good evening, everyone. Welcome back. Welcome to the first session. I think we just waited for a few minutes so we can get it started. Um, so I think to get started, by the way, I think hope most of you were there yesterday. Like even whoever it is not there yesterday. So just to start with the technical things. So here is the list of things that we're going to talk in the training. And coming to the roadmap, this is the same roadmap which I have shown yesterday, by the way. We are going to start our training with the Linux, and we're going to get into the project. So today's session, we'll be talking about some history about uh, why we need to start with the Linux. And even before to that, okay, we would like to recall what we have discussed yesterday, which is about roles and responsibilities of a DevOps engineer. So if you look at the um, roles and responsibilities of a DevOps engineer, so we have talked about I have not. Yeah. So the yesterday I already gave the context that the market that which is going to give us the job, by the way, which is SDLC, and in the SDLC, by the way, so the web applications is the one majorly which we are trying to uh, focus. Basically, the larger business area is web application, so we'll be looking into that, and where our role is also very important in that particular area. And here, as a DevOps engineer team, so it will be developed by the development team. So we already talked about in the SDLC, and the testing will be done by QA team, and the engineering teams will come into picture to uh, release the application, because this application is actually, let me put a small mind map so that you'll understand what I'm talking. Yes. Okay. Right. So now what we're talking about is the SDLC. In SDLC, we're going to talk about web applications, web apps. Now, these web apps is actually in order to be used by the customer. Let's say this web app is accessed by some customer, and that means the end user will try to access this. The end users are actually going to access this one. So over some sort of a URL. Let's say you can say that um, something like www dot so devops.com, something like that. Okay, so as an example, right, some www, they will access it and they will hit our server. Okay, this is what is going to happen, right? Okay, so now as a DevOps engineer, so what you're actually doing is in the SDLC, by the way, so you have different teams involved. Okay, so the teams which are here, which I'm saying is you have a development teams, developers you can consider, and after that the QA and the engineers who is going to host this application uh, on the servers, and it which is made it as a public and using, right? So these are the guys' responsibilities is this. Okay, engineers are coming into picture, SDLC. Okay, so teams in SDLC. There are different teams in SDLC, by the way. So after developer giving to QA actually once it is done, so the engineering roles comes into picture. So because we're talking about web application, the web application somewhere we have to host in the server. It can be a cloud, on-prem, our own data center, or a cloud. Okay, somewhere we're accessing some website. Okay, let's say you take Miro.com only. Okay, so I'm hoping this is being accessed. I mean, this is there in Amazon only. It hosted in Amazon. If I'm interested, you can check it out. Like, so Whois, there is a website called as Whois, which can help you in searching a website where, I mean, who owns it, by the way. So Miro.com, if I search for, so search for that, and it is going to give me, oh, it is actually not this. I need to search um, Whois, or let's go for this Whois, this who.is. This is it. Okay. Who.is the website. Now, if you look in, you can see that the registration done by Amazon. Okay. All right. So this is all having the Amazon DNS records. Okay. So you'll understand this, all these things. So anyhow, we will host our application. So that time you can see all this information about our project as well. Okay. So this is what is the information. Right? It's a public information generally. Any websites, it's a public information. Whereas some companies will try to hide that information also. Like let's say www dot, or maybe simple google.com is okay. So if you try to see that information, the information may not be available. So it is telling information is blocked. Some people will try to restrict that. Some people will try to keep it as open, by the way. So that depends upon the uh, business and things like that. Okay. Fine. And stepping back, by the way, so this is the server. So where we are actually going to host the things. Now, server is something which we are talking about, right? So as DevOps engineers, so we're going to keep it on that particular server. Now, yesterday, one more thing we talked about, which is the roles and responsibilities of a DevOps engineer. So which we categorized as 4 things. One is infra management. So that means the server is running. I need to make sure. Okay, so this is well maintained, by the way. So that is my job. Okay, and I'm going to release the application. So they're going to continuously develop it. So developers are going to continuously, developing the things. QA is going to test it, and they are going to provide to you. And you will work on some release management process, and you will make sure the application is getting a continuous release here. Okay, that is a point. And security. So your application is actually coming exposed to the outside world. So now you need to make sure the security of this particular server is very important, right? Okay, because outside world is actually using it. So sometimes may not be the user. There can be a hacker, okay, who is actually trying to gain start look in some loopholes of your system, things like that, right? So to attain some unwanted access. So you need to make sure that you are actually dealing with this. Okay, so that is another thing. And finally, if you look in, so there is going to be an automation which is involved. Okay, so anything that you're doing around the server or around the project, by the way, any repetitive tasks which are having, you're going to automate it, by the way. Now you look towards the 4 roles what are actually doing. Okay, so what are the 4 roles which are doing? So one is infra maintenance. So the infra which is actually here, you're maintaining that, right? That is one thing. And what is the second thing you're doing? So release the applications, like, so CI/CD, you're taking care of CI/CD as well. And what else you're taking care? You're doing the security of the application and as well as the automation. So now if you look in all the 4 tasks, so more or less it is actually revolving around your, application where it is hosted majorly. Okay. So these are the, um, you know, so if you look in, so the roles and responsibilities is turning around this only. Okay, so where your application is running. Now, where this application is running, in somewhere in your cloud, or so somewhere in your own data center, or it can be somewhere. Okay. So that's where now where these are actually running in your servers, by the way. Okay. Now these servers actually run on the high capacity machines, which we call it as servers. Okay. Either it is in the cloud or it is in the on-prem your own data center also. You are going to maintain them in a very high computing power systems. Your desktops are generally like low computing things, whereas servers are going to have high computing, very faster, so CPUs and memories will be there, and even hard disks as well. So now in servers, yeah, I'm just giving a general idea here. Okay, so whoever is new, whoever is already aware, so it's okay. But whoever is new, we are going to um, so we are going to run the uh, okay applications on this particular high compute capacity servers, right? And these are all in the data centers. Now it is Amazon or any other cloud or even our on-prem. So end of the day, it is going to be a server. And these servers are generally, okay, is going to be stored in the racks. If you see the third diagram, this is how the data center looks like. Okay, so let's say inside data center, if you look in, and here are the, how the inside data centers looks like. Okay, what this guy is doing, right? So he's trying to, okay, remove or keep one server, by the way. So now what he's keeping is a rack server inside a rack. Okay, rack server inside a rack. So the racks are global sizing, by the way, and the servers are also made in a global standard sizing. Like dimensions are quite common. So they will try to insert that particular, server there in the back panel of the rack. So they'll try to connect all the cables. Okay, so this is what it is going to be. All right. Now, these servers are especially called as rack servers. The terminology we wanted to bring in. So it's actually the server sitting in the rack is called as a rack server. So that's it, nothing more than that. Okay, it's a very common terminology in the hardware. We generally call it as rack server. So for an example, there is something called as Dell PowerEdge. So Dell is one of the vendor who sells rack server. So this is how it is, the rack server. And if you look into the, if you open this and you look into the chassis, if any one of you already seen, um, if any one of you actually seen motherboards earlier, any desktop also, so usually those will be like this. So here in your motherboard desktop, sorry, your desktop motherboard, if you have seen it, you always will have one CPU slot. Okay, you'll be having one CPU slot, but here you're having multi CPU slot. All right. And your desktop operating systems. Now, let's say, even though you purchased a heavy motherboard, a server motherboard, and you want to use it for your desktop purpose, so that means you install Microsoft Windows, it doesn't support it actually. It will pick up only one, one CPU in the motherboard, or it even can fail as well. Okay. I don't know the particular knowledge, but desktop operating systems will not run. Only the server operating systems can run here. So that's where servers are always will have multiple CPUs. You see the RAMs, by the way. So there are many slots for the RAM because you're going to have huge amount of RAMs on the server, huge amount of CPU on the server. Okay. So when you open the rack server, the motherboard will look like this generally. Okay. So usually comes with a basic configuration might start with maybe 16 GB of RAM, but it can go till 128 GB, 56 GB, 1 terabyte. Okay, so like this, the more big servers you pick it up, the size can get increased. All right. So when we talk about the servers, keep in mind that these are big servers. Okay, not small servers. Okay. So now I already given some screenshot something for you to understand. So the maximum it supports also, if you are buying the server, okay, the max capacities it can offer, you can see this, it can offer 144 core CPUs, by the way. Okay, 144 is huge. Now, let's say if you are buying your i series of let's say Intel, I mean until at least i7, so it is actually four core CPU. Okay, we're talking about four core of i6, i5 systems. Okay, now there are 144 cores at a max the server can support. Okay, so which means it's a huge. Okay, and it can support even 16 DDR5 slot RAMs. Okay, and which means like 1 TB max it can support. Okay, and there are some 4 TB also with some other customization they're telling. Okay. So there are 12 3.5-inch SATA disks you can add, or if you are going with high performance disks, by the way, so super fast disks if you are looking for, they're going to allow 8 into NVMe or 8 into 2 into 2.5 SATA. These all can be supported, by the way. Hard disks, number of hard disks you can attach also they are telling, right? So it's overall you need to understand the capacity is big. These are big servers are big, by the way. Okay. So in short, if you consider servers are high performance servers, so which are highly reliable, scalable, and does the continuous operations, by the way, behind the scene. And now the question is how actually these servers will run. Okay, these servers also should have some server is just nothing but a kind of a desktop, but a big one. But however, in order to operate it, we require an operating system. Essentially, if you want to run a hardware, right, you require some sort of a operating system, isn't it? Now, that operating system we are going to talk about here, different operating systems, those are actually driving the servers from quite some time. Those are Linux, Windows, and Unix and mainframes. Okay. It all started with mainframes, and then Unix came, and then Linux and Windows came. Okay. So there are worlds even still running, okay, Unix and mainframe. Okay, Unix is very less, but at least mainframes are still running in the market. And there's a big business in the market that which is offloading mainframe. Okay, that means if anyone says that, I'll, if any consultancy, let's say I'm a consultancy like Accenture or McKinsey or BCG, okay, I'll go and tell to any client saying that hey, okay, you have mainframe. Okay, so we can completely offload your business from the mainframe. So this is how we can do the design and do that. That's a big business in the market right now. Okay, offloading mainframes is one of the big chunk of IT work going on in the market. Okay, so that means mainframe, the problem of the mainframe is you have to pay huge amount. The company's already paid huge amount like 30 40 years back for that particular hardware and continuously maintaining it. That is one thing. So they paid for the hardware, and the problem is for using that hardware also every year they have to pay it. Okay, it's not like one time you buy it. Okay, even though you bought it, okay, and based on the number of transactions you make, you have to pay per transaction. Okay, so we generally call it as, I think, MIPS, I think, if I'm not wrong, mainframe MIPS. MIPS means millions of instructions per second. Yeah, so this is what the calculation will come. And so for this calculation, uh, you have to pay, by the way. So like, I mean, so this is too much cost. And there is also a well-known saying in the ITs, by the way, which is like, your 25, if you are running a mainframe, your 20% of IT cost is mainframe only. That big it is. Okay, so that much essentially you have to pay to the IBM. So people are not interested, continuing anything on there anymore, but they can't offload over the night as well. So that's where, any company who is approaching doing the offloading the business of mainframe, it's a very, so a huge business going on in terms of numbers, by the way. Okay, so that means mainframes are still exist. Mainframe developers, engineers are still there, by the way, and they are running. And Unix is wherever I think people are getting chance, they're migrating from Unix to Linux because those mostly looks similar, but the hardware is different. Okay. So, and then Windows is there. Now, when you have different operating systems, now it's an open question that, what is being used in the market. Now, let's say the people we know, they may say that, they are working in Windows. Hey, Windows is everywhere. Other people who are working on Linux, okay, they may come and say that, okay, is everything is Linux, but we don't know the data, right? So the data is a quite challenging. Okay, so that's where there's a Wikipedia link which helps us in understanding the information. By the way, so this is usage of operating systems from the different sources of the data which is collected here, and they tell that you have devices, I think, coming down. So you have web clients. Web clients are, that means like, web clients is Google Chrome, Firefox, these things. So these are, okay, which is the widely used, in which devices it is widely used is uh, Android, it is telling. So everyone knows that it is Android that is widely used. No question in that, right? Now come to that down, by the way, there is a desktop operating systems also will be there. Where is desktop also should have been there somewhere. Hmm. Here, desktop and laptop computers. Now Windows is winning in that area. No one questions that. Okay, most of the desktops that we see is Windows, by the way, right? So no question in that. So the same way, if you come to the, okay, big machines, by the way, and so here also they talk about mainframes and the decline of mainframes, by the way, so in the market. Okay. Now, when you come to the big computers, so if you look at the number, by the way, it's all, with the Unix operating system and then the Linux operating system. So Windows prominence on that area is very, very less, by the way. I think there is a number. Okay, so this is very specifically written for the large computers, but that's okay. But if you look at the server family or the server OS operating systems, Linux essentially crosses 90% easily. Windows is very, very small. Only this recently, like Windows Azure kind of a thing. Even Azure is majority of the percentage is powered by Linux only. Okay, and so there are some systems which are, so essentially on the Windows side. Okay, when you look at the numbers, it don't even cross the 10% of the numbers also. Okay, generally 10-15 at a max. But you generally need to consider Linux is a highly used operating system. Okay, so because Linux offers the stability and performance at a scale, it proven for larger systems. Now we have seen that supercomputers itself will run with Linux. And also it's an open source, by the way, so it's always transparent. Okay, no closed loop like Microsoft, that what's going on inside. We have seen the recently, like suddenly people surprised to see, okay, so how they design the security after I think the major downtime happened for I mean Microsoft Windows this year, right? So I mean everyone was surprised because people can't see what is inside the things, right? They ship with a closing, so they don't have visibility, right? And you have some other flexibilities that you have. So Linux is a dominant choice in the enterprise world, especially. So we are going to talk about Linux. That's where why is the reason that we're talking about Linux with some background. This is why we're talking about Linux, right? Does it make sense? Any questions? So if you have any questions, it is the same process. Please raise your hand in the Zoom. I can come to you if you have any questions. Okay, cool. I don't see any raised hands. So moving on. So the next is, uh, anyhow, Linux is the starting point, which I mentioned, which is fine. And our applications are deployed on the servers, and the servers are now going to run on Linux. So that's where we need to understand the Linux first. And when it comes to the Linux, again, the confusion will come. Okay, why? Because Linux distributions will be there. Okay, so Linux distributions list of distributions in this one. You open this diagram in Wikipedia. There's a huge number of operating systems which are there. And every line is here is an operating system of Linux. So these many Linux flavors are there. Okay. So, but majority will start with one parent, couple of parents. So one is Slackware, another one is Debian, and the third one is Red Hat. And again, the remaining are some individual vendors, by the way. Okay, so three major vendors are there. So and all remaining are the subversions of it. So that means they copy from the parent and they develop something for their customization, by the way. All right. And if you see this lot of lines also will get disconnected, by the way. All right. It's not under parents, but if you go down these, by the way, so I think it's still there. It's okay. So 2024. I think some releases are still going on with them as well. But there are some disconnects also if you see this. Okay, that means the products are no more running. They may be started, but they're not continuing anymore. All right. Now there are different distributions which are available. And if we look in, the popular distributions are is either from the Red Hat or the Ubuntu. Okay. And are not distributions, I would say, like, the popular operating systems from the distributions are, these are at least top 5 you can consider. This is also again some internet information, I just put it in a way. So Red Hat, Ubuntu, Rocky, Alma, and CentOS. So and each of these are derived from the parent. So whereas Ubuntu from Debian and Red Hat, Rocky, and Alma, okay, are Red Hat, Rocky, and Alma belong to one thing only. And even CentOS Stream also. Why not CentOS Stream? CentOS Stream also belongs to the Red Hat under Red Hat only. Okay. Now, out of these, which is widely used again is a question mark. All right. So we need data from the internet. So which is so that's where I went to the Google and I typed the information. So which Linux is widely used in enterprise organization? Okay. So the answer you get it is RHEL, Red Hat Linux. Okay. So Red Hat Linux is so famous because it is proven in the market. Okay, so it has good custom. I mean, a good. Good name overall in the market in terms of support and so security aspect especially. Okay, they deal with that. And so well, Ubuntu actually started first, and actually stepped back or not stepped back in terms of usage. Actually it actually slowed down in the market or in the trust of the enterprise, by the way, because of one of the reason majorly we look towards is um, there's a person who actually the open source you're talking today, right? So there's a guy who actually founded the open source world, which is GNU founder. Okay, Richard Stallman. Okay, the Richard Stallman. Okay, so actually is the first person who actually so decided that a software has to be a free. By the way, it should not be in a closed loop. Then he started a revolution. Then Linus Torvalds joined Richard Stallman, and both together they produced a product called as Linux. Okay, so now today the Linux is still maintained by Linux core. There is a Linux core, we call it up, Linux kernel, that is still maintained by Linus Torvalds only. And and actually these guys together started the things. That's where it is called as GNU Linux. He founded a community called as GNU. Linus Torvalds made the core of the Linux, so they together formed, and it is GNU Linux. Now, GNU founder, okay, Richard Stallman, um, on Ubuntu. So he made a bold statement on Ubuntu, by the way, which made uh, which made Ubuntu step back, by the way. Okay, he accused Ubuntu having some sort of a spyware which is there. So since Ubuntu this okay, no, it is not the one, but he accused. But you just understand that, So they tell that, so they are very poor in security aspects, by the way. So then he told he's moving to Red Hat in for his usage, by the way. So the momentum actually it is in early 2010s this happened. Okay, so that is a era. Basically, Linux is very much moving at a pace and a competition which Linux to use, and Red Hat became a clear winner in the enterprise world, by the way. Right. So overall, if you look at, you talk to any person who works on the enterprise organization, especially who works with the backend servers, you can talk to them. So they'll always talk about something which is Red Hat. Red Hat is major. So that's where we are also going to learn the Red Hat in our training. In Linux, which Linux we're talking about, it is Red Hat. And one Linux, if you learn, by the way, other Linuxes are similar. Most of the time, it is going to be similar only. It will not change much. Slightly some commands and all will change. But yeah, so now coming to the Red Hat versions, there are different versions in Red Hat, by the way. So RHL 7, 8, 9, 10. So last three are still going on, by the way. So because there is a support till 2029 for RHL 9, 2032 for, RHL 8, and 2032 for RHL 9. RHL 10 released this year only, and it is there till 2035. So now which Red Hat version to pick it up? I'm picking up RHL 9. Why? Because as simple as that, it was one of the latest version, and RHL 10 released this year only. Okay, so any version is okay, but still the current one will go with, which is RHL 9. In our training, we'll be going with RHL 9 for our course. I think history is okay. Whenever you have some time, you can go through that. That's fine. And now way to access this Linux is the next question. Okay, right? So we got some history and around it. Any questions before proceeding? Okay, I don't see any hands. Okay, one.
Oh, sorry, I was on mute. Hi, my name is Sudha Rajaprabhakaran.
Yeah.
So regarding this Linux,
Yeah.
are we going to use AWS console to learn this, or are we going to install on our laptop? How are we going to do
Yeah.
that?
Yeah. That's the next topic. I'll come to that.
Okay. Because I have a Mac. Mac is already running on a Linux. That's why I was asking. Thank you.
Okay. All right. Now the question which I got, it needs some understanding of history. Okay. So Mac is running on Linux. The answer is wrong. Okay. So I think it's time to talk about this history also. We have some time. That's fine. So what happened, by the way? All right. So when the compute world started, mainframe is one area, and after that Unix also has been born. So to do the so server-side computing as well. So then that's where a Unix came into picture. So Unix was developed, by the way. So in Bell Laboratories, I mean the first version is there. Okay, AT&T first Unix was there, and from there a couple of Unix came, IBM Unix and IBM Unix or Sun Solaris or HP UX. I think three major vendors especially. So these guys actually ruled the world, by the way. And then, okay, and macOS also. macOS is also Unix, by the way. Now, what is the simple differentiator between Unix and Linux? So Unix basically, they are going to ship together both the software and hardware. They only make the software, they only make the hardware. So that is Unix, which means the MacBook is the only Unix which is currently surviving in the market. They only make the software, They only make the hardware, and now at least from past 5 years, it's a pure Unix box. Why? Because even the CPU also is their own, by the way. Okay, so to that extent, they went right. So that's where it's a pure Unix box. Now this is the challenge. Now this closed loop comes with a, now today what you're facing is, let's say if you are buying an let's say an iPhone, which is also still a Unix one. The problem is the cost, right? So iPhone cost you, let's say, $1,000. The same capacity, okay, if you're looking towards Android, you may get it in 400, 500 also. That means there's always a premium involved in Unix, and the premium involvement was there in the server world also, with the other Unix who are ruling, by the way. And it was becoming very, very much challenge, okay, about uh, so it was becoming very much challenge, so the students itself from the universities, buying a Unix box and practicing it for it. University itself is actually facing the challenge, and that's where Richard Stallman, who is a professor, so who decided that, so there is something, it is not going right. Okay, so the software has to be free, and that's where he started a movement which is called as a GNU movement. Okay, so Richard Stallman started GNU. So GNU stands for GNU, which is an animal name, and after that it's a GNU, not Unix. Don't use Unix. He's against Unix. He formed a community. Then he started, he and with his um, he and with his some of the people who actually joined the community, they started something, you know developing something which is not Unix, by the way. All right. And in parallel, there's another student somewhere. So he also, okay, had the same thought, but these guys actually couldn't able to break. And after that, there is another guy who is called as Linus Torvalds. Okay. So who is a university, again, student. He broken the code and he published the internet, I have this so-and-so code. And these guys actually collaborated, okay, and both agreed and decided, okay, so our both ideas are fine, or both are same, by the way. So we'll go with, okay, releasing a Linux, GNU Linux. Now you take many of the Linux which you see here is all GNU Linux only. Okay. Now what is a Linux means, by the way? Linux as a word, which is not an operating system, but we still use it as an operating system. Now what here we do is, or here Linux means what is basically is, you make any software. Okay, Linux means software. Okay, any software can run on any hardware. The software that can run on any hardware is the idea. And in between, the layer they introduced is called as the majorly Linux. Okay, so this is the history, by the way. So whereas the software and hardware is actually manufactured by the same person, which is called as Unix box. And whereas any software that can run on any hardware. Now, let's say I have shown you previously the Dell PowerEdge. The hardware is manufactured by Dell, but the operating system is developed by, let's say, Red Hat. So there's no relation, right? So it is still running. So that is the idea, by the way. So this essentially bring down the cost because of multiple people involved in competence, by the way, right? So that was the major idea. And so this is what is a Linux. But there's always a question. Now, someone mentioned that, so it's always a confusion. It looks like, I use the same commands of Linux here and Unix also, I use the same commands. There's always a general misknowledge in the market, which is like, Linux is a some subversion of Unix and things like that is there. And yeah, the statement still remains true in a way, okay, in a dimension. But what happened when GNU Linux actually started, developing something open to Unix? That time they decided, okay, so Unix is already beautiful. Unix, no doubt. Okay, why Apple is actually charging premium, even though the price is $1,000? Why I still go and buy iPhone? Why not the Android? Why? Because that premium gives you the feel. Okay, if you are able to bear the premium, you get the premium benefits, by the way. Okay, in terms of comfort, security, and things like that. Even though my MacBook right now, so why I'm still, I mean, why I'm using MacBook here is because it's as simple as that. It brings me a comfort, and for a professional, it is so easy in a way, right? So it's a desktop side things. That's okay. So um now when they decided to make the make this particular another thing, okay, another operating system, so they already decided Unix is already beautiful, okay, it's the best that we know in the market. Why don't we rebuild the same thing, rewrite everything? They did not actually copy it, they just did inspired from they just did a inspiration from the existing operating system and made. So the ls command was introduced in Unix, and GNU actually rewritten that particular whole ls command from the scratch. Okay, so that's where it is. Ls is same, but the purpose is still same, right? So that's where the general confusion is. Otherwise, Unix and Linux are completely a different operating systems, but both look similar, by the way. Both are from two different ways. All right. Not audible, Sudha.
Oh, sorry.
Mm, mm.
So I have this question. So when you say Unix is proprietary hardware and software, right? So the hardware is when you say hardware, is it the same Intel chip? Because Mac has its own chip, and um, Mac supports both both kind M1 and Intel chips, right? So so the Unix can run? Is it like a chip agnostic, so it can run in any of these chips? Is that right? I think that's
Idea.
what.
Servers, no. Servers is completely no. But Apple has relied on the Intel for some time, okay, which went
Uh,
for a toss. Okay, so at least for years they have been complaining. Apple is complaining that Intel has a bug, they are not fixing it. So in 2019, they decided, okay, they go and develop their own, by the way. So that's where they started their own. But that's okay. When you make the hardware, you make the remaining pieces, you made it. Only the chipset, I don't have the I don't have the development within me, by the way. They procured for some time the Intel, and which didn't work out, they moved on to bring their own. But servers completely, they built their own, or they talk to the vendor. Let's say Intel is a vendor, they'll ask Intel, okay, to give a custom chipset for them. Okay, that's a contract again. So but
okay.
it was never
So the Mac,
x86.
so the MacBook was built based on Intel originally. Then recently they moved and they built their own chips. Is that right? I didn't know that history. Okay.
Yeah,
Oh, okay. So, by the way, so Unix is not, to answer my question, Unix can run on any of these hardwares, right? The
no,
Unix
it
also,
won't. It
it
won't run.
won't.
It won't.
It has, so it will run only on specific type of Intel chips and specific type of M1 chips.
Simple answer. You can't run Mac OS on, you take a buy a Dell hardware, Dell laptop. You can't run MacBook on there or Mac OS on that.
Yeah, I understand that.
Yeah,
But when you said Unix, the Unix operating system itself, it has both the software and hardware built together, right? So I understood because Mac is right now running Unix and they are also together, software and hardware are tied together. Is that right?
correct,
Okay. So that is fully proprietary by Apple, the software
correct,
and hardware. Got it.
correct.
Okay. Thank you.
Yeah. All right. So the next is, okay, so how can we get this Linux, by the way? Okay. Now the Linux is, can we go with multiple ways, by the way? You take a laptop or desktop, you install Linux directly, or else you can do some dual booting having, okay, Linux and Windows also. Or else you install some, virtualization tools in your desktop, where you can have Linux installed in a VM kind of a thing, by the way. So all these things can be achieved different ways to get the Linux. Well, all these methods are going to work, but none of these reflect actually the learnings of your or the real-time learnings, right? In the real time, you don't run the Linux on desktop. In the real time, you don't do the dual boot. In real time, you don't run the application on the virtual machines on your desktop. So none of these is actually the practice of the real organization, right? So we also don't want to go into that approach. Okay, so though it is cost effective, maybe, right? But still, I don't want to go into that area. And so spend my energy on doing something which is not actually expected in the job, by the way. Okay, so either you should have an enterprise grade server, okay, which as an individual we can't afford, and you can go to the vendors who offers the servers, by the way. So you can just take the servers and you pay them for what we use. And that's where the cloud, anyhow, our training is based on the cloud. So we'll go with the cloud, and the cloud we are choosing is simple, AWS cloud. Okay, so this is how we are going to come to the server creation, something on the cloud, by the way. But in order to use the cloud, every one of you need to do the AWS account sign up. Okay, there's a sign up which is needed. Okay, you can't get it just directly like that. So it's a very simple sign up form that you need to do. But while you do the sign up, by the way, so you're going to be asked for your credit card and some personal details. You make sure you provide them. And without credit card details or credit or debit card details, you'll not be able to, create the account. But don't worry on that. Why? Because they won't charge you automatically. Okay. So you have to review it and you have to pay it, by the way. So every month. And in the very starting month, by the way, we don't expect much cost, but from at least by the time when the Kubernetes training is going to start, so there is uh, there's a there's a cost which is expected high only. Okay, little high. At least you'll cross $20 at that time. Okay, so until you come here, okay, Kubernetes world. So this cost, it should be less than, so around $10-15 at a max generally. Okay, but once you come to the Kubernetes, you have to burn the hardware to power it up. So that's where we are going to see little more costs crossing $20 at least. And that also depends upon the usage. Let's say if you're practicing some 3 to 4 hours of time, this numbers is right. Let's say if you're practicing like, let's say 12 hours, 15 hours per day, you're burning the things, then the cost will eventually increase. All right. So we need to bear that particular one. So which every one of you need to do the sign up. Okay. And if you already have an account, you don't need to bother about it. You can still continue using the same one. Okay. Now there is something called as a free tier and all. You will see some fancy words. Those are not free. Okay. You need to understand that. They'll just make you, so start using the things. And when you use small things, it is free only, no doubt in that. But however, we yesterday itself, I told you, so we are going to run the big project. The project, what we are going to do here is big project, because big projects brings seriousness. Okay, big project bring seriousness in every aspect that you do, by the way, right? So that is where, okay, ours is a big project, so which eventually don't fall under that free limits, by the way. All right. So please try to set up. If you don't have AWS account, if you already have it, I mean, it's been in some time, you haven't used it, so let's check it out. If it is still active, please continue using that only. Okay, so no need to go for separate one. Like as I mentioned, so there is no free thing that turns out, by the way. And the details are here, by the way. This document is shared with you on the Learnist portal. I mean, so there is a list of links, some document has been created. This document is actually shared there, link, you can access it. And yeah, so these are the how to sign up, and this is where you can sign up. And after that, you can log in here. Okay. So by tomorrow, okay, so from tomorrow only we'll start the actual Linux. By tomorrow, every one of you, please do sign up your accounts and get ready so that after the session, you can go for a practice immediately. Okay, all right. Any questions on this?
So, in order to learn the Linux, why don't we use Docker images on our local computer? Why do we need to go on cloud and pay all this cost? That will be much simpler, right?
So in company, once you join, you can't run everything on the Docker on your local system. Companies won't run on desktop, right?
Yeah, but the idea is to learn the Linux operating
Idea
system,
is
right?
idea is not about the first section of the training is about learn the Linux.
Yeah,
The
for
remaining things
just that I'm saying, just for that I'm saying,
for
because
that also you're
uh,
not going to save anything. Why for that only I need to go for a wrong road? Okay. I can still go for the right way only. It's fine.
I didn't know how much AWS is charging for Linux. So that's why I was saying, because I have the account, they charge a lot for every single thing. So I was wondering if we could save some bucks. That's just an opinion. That's a suggestion.
See, the amount of time you spend, I look time versus money. The amount of
Mm.
time I spend to learn unwanted things rather than that I learn a wanted things, which gives me a better outcome. Okay. The amount you save, a couple of bucks, is nothing for the time you're saving. Okay.
Okay. I was just curious. I haven't used the Linux terminal on AWS. I didn't know how expensive it was. So that's why I was saying.
So I already set you the cost. Okay. So
Oh, okay. It's only 20 to 30 per month. Okay.
right.
Got it. Thanks.
Yeah. All right. So the next thing is some quite basic introduction on about Linux only. Anyhow, we'll start it again from tomorrow. So once our server is ready, so you will generally see that you're going to connect over a command line. Okay. So you'll be having, if you are using Windows, you'll use some clients, or even if you are using MS-DOS and all also, it can work by the way. But however, in Windows, generally we'll prefer to have some additional client installed. And some Mac OS also, it is the same thing. So people can go with installing additional terminals like me, what I have done, or else there is an inbuilt terminal, which you can use as well. Okay. So either of the one should be fine. So the client is your choice. We don't mind. Even the browser also give you the clients. Okay. So you can go here and search for, as such client, what is that, plugins in Chrome. You can directly, have some client available as an extension here also. Okay. There are many ways of how do you connect to the servers. Okay. So that doesn't matter. But however, you need to understand it's going to be a black and white screen. So when you are actually dealing with a server, it's going to be a black and white screen. And yes, being a graphical user for some time, maybe you feel graphical is so comfortable. Okay, so that I can go here and click on that. I know what is happening and things like that, right? But being a professional, okay, that actually is a lazy thing that is going to happen. Okay, you all the way you take to the mouse and you do a lot of clicks. Okay, it's the most laziest way, the laziest thing that you're doing. Okay, and over a period of time again, right? So when you actually try to stuck with Linux, okay, so then you start understanding the power of command line and a power of command line, and you'll start feeling that so the graphical systems are much lazy and it can not give you the so best outcome. By the way, a simple example I'll tell you. If I were asked to modify a text file, okay, so like you replace some word with one word. Okay, then what you do, open the file with some sort of a editor. Okay, in Windows, right click, open, go there, search it. Okay, so search for that word and replace it. Very happy path. Now the same work, I asked you to do it on 100 servers. Sorry, 100 files on the system, by the way. So then what you do, you go there, right click, open, search, paste, search, paste, search, paste. You end up your day gone there, right? So that is not the right way. Okay. But whereas you go to the Linux, if it is one file or 100 file or 1,000 files, okay, the compute time is going to be very minimal. Okay. The same operation can work on 100 files, one file. Okay. Just in a minute, it will do the job. Your tasks are related, okay, for a corporate work kind of a thing is actually going to be a winner there. Windows also you can do that. If you're actually wanted to do that in Windows, okay, you can still go ahead and do it on the Windows. Okay, that means from the command line, you should be able to still do that. Okay, efficiently. But if you're doing command line on Windows, how does it matter whether it is Windows or Linux, right? It doesn't matter. So that is where, okay, so command line is what we are going to use. Anything you want to do is a command line. And the command line is lightweight, so that's why it is very faster. And you power up your Windows or Mac OS, I don't know, like some reason the CPU is always some part used, memory is always some part used. We even don't have a clue that why it is running. But whereas you go to the Linux, it can start even from a 10 MB also. If your RAM is 10 MB, a Linux can be start powered on. Okay, to that minimal, it can run. So that's where it is going to be a lightweight because it is a command line, because graphical is a bulky, you require a lot of software to install, and that's where it becomes challenging in terms of running it. Okay, and it consumes fewer resources, and lesser the software. This is very important, by the way. Lesser the software, okay, lesser the security risk. Okay, lesser the software, lesser the security risk. There's a very simple phenomenon that we follow in the production world. As long as your server is running with a less amount of software, the attackers who is going to attack to the system is always less. Okay, so that is where, I mean, a very basic fundamental principle we use there. We'll not install softwares in the servers as just like that. We'll make sure those are necessarily needed, then only those softwares will cooked in. And it allows for automation scripting, like as I mentioned. Right? So Linux is for professionals, as I mentioned. So over a period of time, you will start feeling Linux is far better, or command line. Let's not put like too much as Linux, by the way. Linux has good utilities. And of course, you end up with Linux saying good only, comparing with our Windows, but still command line is much more for professionals. Okay. So that's where you'll start learning the things in a command line way. Linux is more towards a command line operating system. Though it has graphical, we don't want to go and install graphical for the Linux. Why? Because more the software, it is a risk which are going to enabling. By the way. So I don't want to get into that. So we'll always go for a minimal things, and what all the things necessarily needed to run our application, will run for that. And also you can have a question like, how to open a PDF, how to open a movie in Linux. These are all, no, we are not actually doing that job here. Okay, those are different. Those are for desktops. We're not actually using server for that, opening a PDF file or things like that. Okay, or opening a movie, playing a music. This is not I am using the server for. Okay, so we largely use it for compute purpose. All right, and one last thing that generally comes into the picture when we talk about Linux, how much Linux that we need to learn. Okay, this is a very general question that I usually hear. And I would like to try to ask yourself to compare how much, let's say if you are using Windows, how much Windows you know? 100% of the Windows? Definitely no. Okay, and how much are you knowing? You know how much to run for your job, right? And if you don't know, probably you look for the information. It's as simple as that. Linux also is an operating system. It also should be learned what it needed to learn for. I mean, what your job it depends upon. right? Your job depends upon, or your job is to an extent you need, you will go that extent only. You'll not go beyond that extent, because we'll always look for ROI, right? I'm investing my time and energy on something. I'm expecting that brings a value tomorrow. Okay, because I join an organization or something. Okay, so let's say I spend 1 year in learning Linux. Then if I go into the job, by the way, none of the things what I learned I'm not at all doing here, right? Like your education here, right? So the things which you learn in most of the things you learn in your education is nowhere actually you're getting implemented in your job. Isn't it? I'm an electrical engineer, so doing the software engineering job. There's no point of me doing that education, right? There's no ROA at all, isn't it? So that's where we always look in that context only. Consciously, we're talking about here that, so in this starting course of the course, you end up 40, 50 regular commands that you're going to perform. And beyond that is always, so you have always the data available on the internet. You should start reading it when there is a need, by the way. So, but I think 80, 90%, 80, 85% of the job will run with this only. So it should be fine. All right. So how much we are going to learn is we are going to learn how much I need to know for my job to do as a DevOps engineer. Okay. That is the final point. And that's where I'd like to conclude for today's session, maybe a bit early also, that's okay. But I want every one of you to create a AWS account and sign up for it. And from tomorrow, we're going to create the servers and we're going to proceed with learning the actual Linux. All right. Yeah, that's all from my side for today. Or even we have some time, but anyhow, any questions, please go ahead. Otherwise, I'll take a few more.
This wedge is from 7 a.m. to 8:30, right?
Correct.
Not 7:30.
No, 7 to 8:30. Yeah.
And the Kubernetes we will be using EKS, right?
Correct.
So we will be deploying using help charts or without help charts
We write Helm charts.
for the projects.
Not only one Helm chart, by the way. Okay, so it's completely, let's say if I go to my previous batch, there are many Helm charts we should be using. One is only our project related Helm chart, but you have to have other softwares related Helm charts as well, right?
So we will be using RoboShop end-to-end project,
Right.
right? From the servers to Kubernetes, like.
Right. So here we are going to install many Helm charts, by the way. So these are all different Helm charts that we use. It's all completely we're going to use there. So not just one Helm chart for project as well.
So all manifest files are now automated here.
Correct. That's the purpose of Helm.
Not only Prometheus, Grafana, all things.
Correct.
Thank you, sir.
Yeah.
Hi, Raghu.
Yeah.
Hi, Raghu. This is Ritik. Can you briefly explain that? Are you going to do on big project you told, right? Can you give a short intro about that?
Like what kind of intro you want?
Like how we are going to start and the platforms and tools we are going to use.
That anyhow will come as a part of journey, like in couple of sessions.
Okay.
Yeah.
Yeah, hi Raghu. This is Kiran.
Yeah.
Yeah. So is this AWS free trial account is sufficient for all the labs?
No, as I mentioned, so the free tier is not a free tier at all. They'll not give you much anything on the free tier. There is always a limits. If you look at the free tier, they're not giving you anything free.
Okay.
We go beyond that.
Okay. Okay, got it.
Yeah. But when you're signing up, you will be choosing a free tier account only. So
Okay,
just say
but
it as
still,
free, but
Mhm.
anyhow you go beyond free, you have to pay.
Okay, okay, fine. And for the Kubernetes cluster and also we are going to do in the AWS only, right? So
Right.
yeah, okay. Okay, fine. Thank you.
Yeah. All right. And yeah. The next things are basically like when we go for AWS, it's all about AWS contextually. We'll see tomorrow only. It's okay. We're not gonna take much time as well. We'll see tomorrow.
Hello.
Yeah.
Yeah. Hi, Raghu. Apart from the live session, do we have any prerequisite videos or anything before, like
No,
for joining the
no,
session, which we need to cover up and come?
no. It's going to be a live session.
Okay. Thank you.
Yeah. Any other questions? If anyone don't have any questions, feel free to drop. I'm also stopping the recording as well. And